Hello everybody, my name is Hunter Ream and I will be talking to you about Generating Functionology by Herbert Wilf. In particular, we're going to be talking about section 2.3, the calculus of exponential generating functions. This is the second part of a three-part video, which will be talking about the second rule. The first part covered the first rule, so here's rule 2' of the calculus of exponential generating functions. So if f is an exponential generating function for the sequence a sub n, and and we'll say p is a polynomial, then p x d f is the exponential generating function for this sequence, p of n times a n from 0 to infinity. And this seems sort of strange to consider, but it's really not. This is a very natural thing to want to consider. And here's an example to explain what we're actually considering. So find the exponential generating function for n a sub n, 0 to infinity. Now notice, what is this? This piece right here, this n right before a sub n, well, this is technically a polynomial, right? This is this p of n, this single linear polynomial. Well, we can imagine that maybe some more complicated expression was here, not just an n, but the goal right now is just to consider this easy polynomial and see if we can do it. So, what are we going to do? So let f be the exponential generating function for the original sequence. And here's the solution. So since f would be identically equal to this infinite polynomial, the exponential generating function, then the derivative of f, what our rule says is that you should really just consider taking the derivative and then multiplying by x. But this operation here, taking the derivative and multiplying by x, you want to do it in every single element of this polynomial. So what does that mean? Well, if I put xd into just n, then that's just a single xd. So that what I'm going to do is I'm going to take the derivative and then I'm going to multiply by x. So I'm just going to do that a single time. First thing I'm going to do, take the derivative. And how I do that is I do it term by term. So to do it term by term, we can just take the derivative as we would. We get an n a sub n over n factorial x to the n minus 1. And then if we multiply by x, which the rule tells us to do, it just changes the exponent on the x back to n, which is great. And now this is indeed the exponential generating function for n a sub n. So that concludes Rule 2. Thank you for listening.